Hey everybody, this video is going to go over the solutions to the chain rule exercise worksheet that I passed out in class. So here we go. Our first exercise was f of x equals 2x to the third plus 9x all to the fifth. We need to find the derivative of this because it's got this fifth power out here. The easiest thing to do is to use the chain rule. So the chain rule says that you do the derivative of the outside function. So we've got something to the fifth power. The derivative of something to the fifth would be 5 something to the fourth. Now what goes in the parentheses here is exactly what was in the parentheses before. Just like that. Now we've also got to consider that this inside the parentheses is not just ordinary x. It's got to it's got its own derivative, so we've got to multiply by the derivative of the inside, which is going to be 6x squared plus 9. And there's not much you can do to simplify this. You could, I suppose, if you wanted to, take this binomial and move it to the front so that the fourth power binomial is on the end. That probably would look a little more normal, but either line is acceptable as a final answer on a test. Now number 2 says f of x equals negative 7 times 3x to the fourth plus 2 all to the negative fourth. Okay, so now this is again a expression raised to a power, so we're going to need the chain rule, but also we've got this coefficient here, this negative 7. So let's leave the negative 7 in the front there, and we'll do the derivative of something to the negative fourth. So we bring this negative 4 to the front, and that drops that power to negative 5. Now what's in the parentheses here is exactly what we put in the parentheses here. So the inside of that parentheses will be 3x to the fourth plus 2. And then we've got to multiply the inside of the parentheses derivative. So the derivative of what's inside is going to be 12x to the third. Okay, so again, negative 7 times the derivative of the outside function, so that's, negative 4 parentheses to the negative 5, and then times the derivative of the inside function. So that would be the derivative of the inside. Okay, now we've got to clean up our answer a little bit. We would never leave a negative exponent in our answer, so we'll be moving that to the bottom so it can be positive. The negative 7 times negative 4 make positive 28. Okay, now we've got monomial times monomial here, so we may as well go ahead and work out 28 times 12. 28 times 12 is 336. So we end up with 336x to the third all over that binomial to the fifth. Alright, our third exercise says f of x equals 12 times 2x to the fourth plus 5 all to the 3 halves. Now it may bother you a little bit that we have an exponent here that's a fraction, but don't let that bother you because the chain rule is going to work exactly the same way. First of all, we know the 12 just sits out in front, so f prime will be 12 times, we'll bring this 3 halves to the front here, so 12 times 3 halves. And then we're going to drop this exponent by 1. Now 3 halves minus 1 is 3 halves minus 2 halves, which is 1 half. And the inside of the parentheses remains exactly the same. Okay, now we've got to multiply out here by the derivative of the inside here. So that's going to be 8x to the third. And we can clean this up a little. Now, 12 times 3 is 36, and 36 divided by 2 is 18. Okay, and then I kept my parentheses to the 1 half, and then our 8x to the third. Now I have a monomial on both ends here. I have an 18 and an 8x to the third. So we may as well multiply 18 times 8x to the third, and we'll have 144x to the third times 2x to the fourth plus 5 all to the 1 half. Here's number 4. We've got f of x equals 8 times the square root of 4x squared plus 7. Let's rewrite this in a more derivative-friendly form. So I want to get rid of the radical and replace it with a 1/2 power. And now, because it has a power on the outside, we'll use the chain rule. The 8 will just sit in front as always. So the derivative is 8 times this exponent, 1/2, times parentheses all to the negative 1/2. Now it's negative because you know 1/2 minus 1 is 1/2 minus 2/2, which is negative 1/2. And the inside of the parentheses remains exactly the same. And now we have to multiply out here by the inside of the parentheses here. So the derivative, or rather the derivative of the inside, so the derivative here will be 8x. And now let's combine all of this. We have 8 divided by 2 will make 4. And that 4 times this 8x will make 32x. And you can see I've gone ahead and moved this expression to the negative 1/2 down to the denominator where it could be positive 1/2. And I've also gone ahead and replaced the 1/2 power with a radical. And I figure just because the problem came with a radical form instead of a 1/2 exponent, let's leave the answer in radical form as well. Now here's number 5, and this is f of x equals 4x times 2x to the 5th plus 3 all to the 4th power. And this is the first time that we've seen actually a function multiplied by our expression that's raised to a power. Up till now we've always had constants out front like a coefficient, but now we've got 4x. And so we'll have to treat that like a function because this is f of x. X is a variable. So what we'll do is this is 4x times the rest. So since it's times, we'll plan on using the product rule. I'll say that the first function is 4x and the second function is 2x to the 5th plus 3 all to the 4th. And now we'll do the derivative of each of these. And the derivative of 4x is going to be 4. And the derivative of this binomial to the 4th is, we'll need the chain rule here because of this outside 4. So that'll be 4 times the parentheses to the 3rd, and then times the derivative of the inside. So the derivative of 2x to the 5th plus 3 is going to be 10x to the 4th. Now, I have a monomial here and here, so we may as well combine those both into 40x to the 4th. And then here's our binomial to the 3rd power. Okay, now it's time to use the product rule. So we'll have the derivative of the first function times the original of the second function plus the original of the first function times the derivative of the second function. Okay, now just to clean things up, 4x times 40x to the 4th would be 160x to the 5th. Now on a test it would be perfectly fine with me if that's as far as you went. However, in the book they will usually do one more step because we have this binomial to the 4th here and the same binomial to the 3rd here. So what they typically do is they'll factor out the 2x to the 5th plus 3 to the largest power they can, which is the smallest one that you see. So we could take 3 of those away from each term. And also notice that both of these coefficients are divisible by 4. So I used 4 times this binomial to the 3rd as my GCF. Now inside a pair of brackets I'm going to need the other 2x to the 5th plus 3. And I'm also going to need a 40 x to the 5th. Okay, now check it out. If I did this expression times this, would we not get 4 times 2x to the 5th plus 3 all to the 4th power? We would. And if we did this expression times 40x to the 5th, we would get exactly this expression. So the factoring is okay. Now we may as well combine like terms inside these brackets. And I really, now that I see what's in here, I don't really need brackets. It would be totally fine to use parentheses because we're going to be able to get rid of this inner pair of parentheses. And that's going to make 42x to the fifth. See, 2x to the fifth plus 40x to the fifth is 42x to the fifth. And then our plus 3. And then all the rest that was already in front. Here's number 6. This is x to the third plus 2 times x squared minus 1 all to the fourth, and we want the derivative of this function. Again, because this is two functions multiplied together, we'll use the product rule. So I'll separate it into x to the third plus 2, and that derivative is going to be 3x squared. And then the other function is x squared minus 1 all to the fourth, and for that derivative we're going to need the chain rule. So I'll do 4 times that binomial to the third, and then times the derivative of the inside, which is 2x. And I'll go ahead and clean up this 4 times 2x really can be written as 8x. Okay, now for the product rule, we say the derivative of the function is equal to the derivative of the first part times the original of the second part plus the original of the first part times the derivative of the second part. Okay, so here is our product rule, and we just need to clean it up a little bit. First of all, well, I guess rather than distributing anything, we could just notice that we can go ahead and factor out the x squared minus 1 to the third power, because we take the smallest power that is there, or in other words, the biggest one that's common to both terms, and in that case that would be x squared minus 1 to the third. So I factored that out. If I take x squared minus 1 to the third away from this term, it will leave the 3x squared, which I have here, and the x squared minus 1, the extra one that's, you know, not included in this, what I factored out. So there's one left there. Now think about it. If I do that thing to the third times this, it will look like that. Okay, now if I take the x squared minus 1 to the third away from this term, what's left will be the 8x times the x cubed plus 2. I went ahead and distributed the x squared here and the 8x here, and that gave me 3x to the fourth minus 3x squared plus 8x to the fourth plus 16x. Okay, now combining like terms, we have 3x to the fourth plus 8x to the fourth, that's 11x to the fourth. And then we have minus 3x squared and plus 16x. And all of that is being multiplied by that cubed binomial that we pulled out before. X squared minus 1 all to the third. And here's the last exercise on this sheet. It says f of x equals 1 over 3x squared minus 4 all to the fifth power. Now, you know I'd do anything to avoid the quotient rule, so rather than use the quotient rule here, I would move that binomial up to the top and give it a negative exponent. And now I'll use the chain rule. So the chain rule is going to be bring the negative 5 to the front, and then leave the inside of the parentheses the same and drop the power by 1. And now we have to multiply by the derivative of the inside, and the derivative of the inside is going to be 6x. Okay, now this needs to be combined. The negative 5 times the 6x can make negative 30x, and I'll move this negative 6 power to the bottom, make it a positive 6 power, and here I've just done negative 5 times 6x is negative 30x. So here is the derivative for this original function.